An air bubble of radius r equal to 1 millimeter is inside of liquid of density which is 2000 kilogram per meter cube, and at the instant bubble is rising upward with velocity and which is constant half centimeter per second. Find coefficient of viscosity. So this is straightforward from the chapter of this Stokes law in the fluid mechanics chapter, right? And it's talking about that terminal velocity. Okay, so if you recall the concepts that are involved here, there's an air bubble and it's going up with a constant velocity. So obviously what forces are acting on it? We have a force which is acting actually downward, it's gravitational weight. But for gravitational weight of air, right, so you will take the density of air. So I'll write down rho of air volume into g, and then we have a buoyancy force up, rho of the liquid volume g, and then since it's going up, so we will have downward viscous force 6 pi eta r v. Now since it's going with constant velocity, so forces should balance, net force should be 0. So 6 pi eta r v plus rho of air volume g should be equal to rho of liquid volume g, right? So overall, since rho of liquid is very much larger than rho of air is around 1 to 2, somewhere around that value, and look at the rho of the liquid is 2000, so just ignore it, no issue in that. Okay, so we'll ignore this weight of the air which is inside the bubble. Okay, so we'll just go with this formula now. So velocity can be found from this formula very easily. Let's have a look at the calculation part. 6 pi eta is we have to find r is given half 1 millimeter, so it will become 10 to power minus 3 meter, and the speed is half centimeter per second, so I will write down half into 10 to the power minus 2 meter per second. Okay, and then is equal to density of the liquid 2000, volume 4 by 3 pi r cube will become 1 ka cube into 10 to the power minus 9, right? So this is overall the picture, and g you can take roughly around this number as 10. Okay, if I take it like this, now if I do this equation, we will get the speed answer. Okay, so let's do the calculation part here now. The calculation part gives me eta from here. Okay, so some calculation wise pi and pi cancel, and then we have here 2, and that's it. I think we should go forward with the calculation part. So 2 4 ja 8 by 3 on the right side, and 10 to the power whole thing is 10 to power, this one is 3 minus 9 and 4, so 10 to power minus 5. Okay, and then will come from the left hand side on the right hand side, right, divide by 6, and then up will have 2 and down will have 10 to power minus 5. So these numbers are already getting cancelled, 2 1 ja 2 3 ja, overall this becomes 8 by 9 meter per eta. Sorry, my this is going to be the eta. Okay, so we'll take this one as eta over here. Okay, so we have now finally the answer. Eta becomes 8 by 9 with the SI units, which is Newton second per meter square. Okay, so which option is matching? This is going to be the fourth option. So with this coefficient of viscosity, we will have this particular velocity constant. Okay.